Today what we're going to talk about is trigonometry. This is the first section and first video to our pre-calculus trigonometry feed on YouTube. So this is going to start off with circular functions. And like I said in my last video, I think I said it in my last video, if you guys have any video requests that you want, any topics dealing with anything in any math, calculus, geometry, statistics, anything dealing with math, and you want a video done on it and some really rigorous examples, just send me a message, comment up under any pictures. I'll probably see it, and or email me. It's in the link is in my bio as well. Just do that and I'll make a video for you. Give me a couple of days to do it. Okay, so what we're going to talk about today is initial sides. We're going to talk about terminal sides, what is an angle, positive angle, negative angle, standard position, and we're going to lastly end with coterminal angles. So let me go ahead and start that off here. Let's see here. So what is this here? You should remember this from third grade geometry, but what is this? This is what we call a ray. Now, what happens when we add this ray? And let's say, now, would this be a ray as well? Give me 1 second. I don't know. Would this be a ray as well? This one and this one, would they both be rays? Because, like I said, a ray, what it has to have is one endpoint and then also one arrow extending to infinity. So I see one endpoint here, and I see this extending to infinity. Then here I see an endpoint and extending to infinity. It's just sharing an endpoint, which is still fine. What we actually call this is an angle. So that is an angle. So I just formed a definition for you, whether you knew it or not. I did. We took one ray and we took another ray, and then we had it, they intersected at one vertex. And that's what forms an angle. So, like I said, so what an angle would be, a general definition, an angle is two rays that share a common vertex. So, two rays that share a common vertex. Okay, so an angle is two rays that share a common vertex, as we can see here. Okay, now, with that being said, let's take another angle here. Let's take this angle. Let's see here. Okay, so I'm going to introduce you to two new vocabulary words. You probably don't know them yet if you hadn't had any experience in your had any previous advanced trigonometry classes or basic trigonometry classes, if you will. But we're going to talk about different sides. We're going to talk about the first side, which I want to call the initial side. This is what we call the, let me write that a little bit smaller. I did write that kind of big. But we're going to call this the initial side. Now, what the initial side is, the beginning position of the ray. So it's where the ray is starting. And it rotates about the endpoint, which we call the vertex. And I'll tell you exactly what I mean by rotates about it and everything like that. Now, the second side that we have is what we call the terminal side. And if you are pretty smart, you can pretty much figure out that the terminal side is the ending side. It's the final position of the ray here. So we're going to go through and I'm going to show you rotations of these different angles and how it works. Now, everything that we're going to be dealing with is going to start off in something called its standard position. Its standard position. And let me put that down here for you so you can have it for future reference. Standard position. Okay, And what standard position is, we usually place an angle in this position here when we're dealing with it in a coordinate plane or a Cartesian plane. The vertex is at the origin. That's one thing. And also, the initial side usually lays on the x-axis, on the positive x-axis, if you will. So the initial side lays on the positive x-axis. Okay, a quick recap here before we move on to anything more talking about coterminals and everything. An angle is actually a ray, two rays that share a common vertex. That's what an angle is, and I formed it here for you. We have an initial side of a ray, of an angle, which basically is where the ray begins. And we also have the terminal side, which is the ultimate or last position, if you will, of our ray here. And they, of course, they share a common vertex. Now, all of the angles that we're going to be dealing with are going to start in standard position. When standard position is it has the vertex at the origin, and also the initial side usually lays on the positive x-axis. So if you wait a second, we're going to actually right now do that here. Let's see here. Let's say we have this Cartesian plane here, just to draw it. And let's say I have an angle that's going up like this. Let's say that's an angle there. That looks like it's about 45 degrees there, doesn't it? 45 degrees splits that 90 right in half there. So let's say I have this. Now, I just formed an angle, as you can see here. This angle here in this section, I just formed, oops, give it a second here. Yeah, I just formed that here. And what we'll see is that this is actually its terminal side here. This is its terminal side. Well, I guess you're saying, if this is the terminal side, where is the initial? Well, the initial is actually right here. Remember what I told you. When we're dealing with standard position, the initial side will always start off on the positive x-axis. So this is actually the initial side right here. The initial side. That is what that is there. So terminal side right here, initial side right here. Now, we can actually see something here, and I'll do it next on the next video once we I'll do it on the next video, not the next video, but the next section here in a second. Let me give you a couple of example problems, and we'll go from there. I'm going to pause the video and let you do them, and then we'll go over them. Let's see here. All I'm going to ask you to do in these three examples is identify for me the initial side and also the terminal side of each angle. So let's see here. If I have this, oops, don't know why sometimes the computer just deletes it. Then I'll have this here. Now, I forgot to mention this to you here. This is what we call a negative angle, clockwise. Negative angles, they're going to go clockwise. Positive angles are always going to move counterclockwise. You see this is moving in a counterclockwise position. That's a 12 right there, a 1, a 2, and it's going backwards in a counterclockwise position. That means it's positive. This is going here. That's a 12, a 1, and a 2 is going in this direction in a clockwise position. So negative will go in clockwise, positive will go in counterclockwise. Okay, let me take those numbers down from there so you guys don't get confused. Okay. And the last one here that we'll draw, let's see, let's not do that one just yet. Oops. I have to fix this. It keeps jumping back up. Let's do this one here. Okay, so I'm going to pause the video here for you and allow you to you can pause the video here and go ahead and find the initial position, the initial side, and also the terminal side for each graph here. Okay, so what we're going to do here now, we're going to actually identify the initial side and then the terminal side of each of these graphs here. Now, we see right here that you only see one arrow. But remember, we only see one arrow going. But remember what we talked about first. We talked about standard position. And what standard position said here at this big bullet point, what it actually said was that the vertex is at the origin, and also the most important part is that the initial side lays on the x-axis, on the positive x-axis here. So what we're looking at is, where's our positive x-axis? We know this is x and we know this is y. So positive x-axis would be this here. We know that's there. And of course our vertex would be here. Let me put that in a probably be best in a blue. We know our vertex is there. Now, before I identify the size that we talked about, let me go ahead and do it for this one here. We have the positive x-axis here as well, and the vertex is there on the origin, and then again we have it here. We have the positive x-axis, which is going to be our initial position, of course, and we also have the vertex. Now, don't these look exactly, these angles here look exactly like the one I drew for you in the beginning right here with the two rays coming together? So that's exactly how you know everything is checking out, because it's all falling into place. We have our terminal sides, which are two different rays, our terminal side and our initial side, which are two different rays, one starting position of a ray, and then the terminal side is the ending position of the ray that for this angle here. Now this would be the initial side, we'll just abbreviate it IN, and this will be the terminal side, we'll just abbreviate it TM. So terminal and initial. This is the terminal, this is the initial here, and then this is the terminal. This is the initial here, and then this red here is the terminal. So it's pretty easy to identify the terminal side and the initial side of it, because like I said, what we do it in is standard position, so it's pretty easy to identify. Now the last thing that we're going to talk about here, everybody pause the video if you need to write this down. The last thing I'm going to talk about here is coterminals. I need to erase this to get some room. I may be able to actually, let me see, be able to actually go down a couple of pages. Let me see here. Okay, yeah, I'm able to go down a couple of pages. So let's look here. Coterminal angles. These are very easy to understand. All coterminal angles are basically saying they have the same initial side and the same terminal side, but their angles measure differently. But they have different measures. So they have the same initial side and the same, I don't know why this pen is dragging, and the same terminal side. Okay, so same initial side and same terminal side, but the main thing is that they're, well, not the main thing, but it's one of the factors here, but different measures. So let's say the measure of angle 30 would be different. If this angle is measured 30 and another angle would measure 460 degrees, just for example. Okay, so let's go ahead and actually show you how we would find coterminal angles. If your teacher asks you, let's say your teacher gives you 30 degrees, and she says, well, I want you to find the coterminal angle that goes with coterminal angles for 30 degrees. What we use is a coterminal angle. Whenever they always differ by either 2 pi in radians or 360 degrees. So we're going to write that. That's an important point. they differ by 360 degrees or 2 pi. And since they differ by this, it's really easy to find it. What we can do here is we'll take 30 degrees and we'll take 30 degrees and we can add 360 to it. And we get 390. Very simple. 390 is a coterminal, and I'll show you that exactly how in a second here. So that's 390. Now what we can also do, we can take 30 and subtract 360. And we'll end up with negative 330 degrees. That is a coterminal angle. So these two here, these are what we call coterminal angles. Coterminal angles. Okay? Now, I'm going to show you based on graphing, how we did before, how they have the same standard position and how they have the same initial side and that good stuff there. I know this video is getting a little long here. We're going to cut it right after this and continue everything on the next video. And of course, if you have any questions, just leave the comments below and I'll answer them for you in a following video. Now, let's see. Let's do this as 390 degrees here. We'll do negative 330 degrees there. Okay. So, 390. We'll both start off with 30 degrees on both of them. 30 degrees is about right here. And this is how we're going to know that they're coterminal. I'll show you this. So we say that's 30 degrees. Then also that's 30 degrees. Okay. So now when we're graphing, if you're told to show on a Cartesian plane 390 degrees, this is exactly how you do it. You start here from the initial side, which is right here. We don't really have to identify it right now because we know that our angle is in standard position. So what we do, we start from the initial side and we basically go around that many times. So 390, we can go around 390 degrees. Let's go around a full 360 first. Let's go around a full 360, which will be right here, 360. Now 390 is going to be just a little bit past there, which will probably be about right there. Not much past, but it's just a little bit past 360. So this would actually represent 390 degrees. And let me write 390 a little bit more clear so you can see that that's 390 degrees. Now, like I said, just to make sure you understand, the only thing that we did here was we went around this many times. So 360 degrees, we went around one full time, and then that means it's 30 left. So we went around just about 30 degrees, which will get us right back to that angle there. Now, let's go to negative 330. What we'd actually do here, we do the same thing. We start from the standard position, but this time, instead of going 360, we're going to go 330 degrees. So I'll show you how that looks. But now, remember, this is a negative. So what did I tell you about negatives? Negatives always go in clockwise position. Positives, they go in counterclockwise. All right, so this is negative, penny here. So this is negative 330, so we'll start here from its initial side, which is right here exactly. We go around, and we don't want to go 360 degrees. We want to go to 330, so we're going to cut it 30 degrees short, which will be exactly at that 30 degree terminal side marker right there. That's exact. Oh goodness, it disappeared. That's exactly the negative 330 degrees that we identify there. Now, just for fun, so you can see what actually will happen later on, and that it'll work, you see that, let me show you this here. We see that we've graphed 390 degrees at 30 degrees. Using this 30 degrees here, we see that we can get 390 degrees. And it has the same, we keep getting back to this same exact side here. We get back. When we stop, we get to that side. How we stopped here, we got to the side before the 30 degree. This, we hit the 30 degree. So you see that how they start at the same point, how they start at the same side for 390. They started right here. I started from here. right there, and I went around, and then it ended right here. That's 390 degrees. It started right here for negative 330, went around, and it ended right here at the same terminal side. So these are what we call coterminal angles. They have the same terminal side and the same initial side, but we're measuring them different values. Now, just for fun here, let me show you this one. Let's say we want to do the measure of, let's do something a little bit bigger. Let's say we want to do the measure. Give me 1 second here. Let me think of a measure to do. Let's say we want to do 360 times 6. Let's say. So we want to do an angle. That's a little long one. Well, that's fine. We can do 360 times 6, which will be 2160. So let's do it. 2160 degrees, so 2160 degrees, just for fun, so I can show you exactly how we would graph this. We start at standard position here, which will be right here, and we'd go around. Now 2160 goes into is divided by 360 would actually give me a 6. So that means I know that 360 times 6 would be this number here, 2160. So I can go around. Since 360 degrees is a full circle, I can do 6 full circles. Since 360 times 6 is that, I'll just do 3 full circles. Okay, so let's start from our initial side, which is right here, and let's go. We went 1, 2, 3, 4, 5, and 6. And about right there. Let me make sure this is, because we did a lot here. So we start off one time and we hit it again. That's 1. We went around again. We hit it. That's 2. Then we hit it again. That's 3. Then we went around again. That's 4. We went around again. It brought us to 5, and then one last time to bring us to 6. So this is actually how the graph of 2160 degrees would look on here. And just to show you, this is the general idea of how we'd show terminal sides and initial sides. And just so you're clear, this here is of course our initial side. And where does this terminal side where's this terminal side of here? It's here, where we have this arrow stopping here. Now it's very hard to see because of course we can't literally draw an angle that big. We can't draw a reflex angle that big. So we use this diagram to denote that it's 2160 degrees. Okay,